Okay, I'm going to discuss this concept. Hmm, Here, K equals to 1 when it is possible from yesterday's concept. Suppose one thermal neutron bombards the uranium, releasing 3 neutrons. Okay, and again bombarding 3 more uranium and releasing 9 neutrons. This is the concept. Okay, in this concept, what we are taking here, 9 preceding 3. So K equals to mean 1 means we have to maintain out of 9, 3 only. Okay. Out of 9, 3 only means here 6 neutrons, 2 plus 2 plus 2, 6 neutrons will be absorbed by someone. Okay. That who will do? Okay. They found there are few materials which can absorb the neutrons even though they are having the energy of nearly 2 mega electron volts. Okay, who are those materials? Here they found such type of materials called as who can absorb the neutrons to maintain the value K equals to 1 are called control rods, Nana.
Good morning, sir.
Good morning, Nana. Okay. So here, who are the control rods? Okay. Control rods means here, its function is they absorb the neutrons, the neutrons. They are capable, the neutrons. Okay. Even though having more energy. Okay. Here, who will absorb these neutrons more, sir? Okay, they found few materials like example here, if you see, like the cadmium, lighter elements, and boron, steel, etc. Okay, uh, absorb the neutrons. That's why they behave as control rods. Okay, out of these two, whose efficiency is more, sir? Means the best control rod. Okay, the best control rod they found here. Next point, what he is saying, um, cadmium rods. Okay, here behave as the best controller, means they are good absorbers, are the best control rods. Okay, this one what they say. Okay, um, when the rods absorb, suppose all the neutrons, then the fission process will be stopped. So we have to take care, Nana, while using the control rods here. For what purpose? To maintain K equals to 1. Why? Previous preceding generation, there are 3 neutrons. So now the present generation also we have to maintain 3 neutrons. Here also we have to maintain 3 neutrons. So 6 neutrons should be absorbed, not all the 9. Okay, that's why to absorb we are using the control rods. But we have to take care. We have to do some scientific calculation here. Out of the 9, 6 should be absorbed and 3 should not be absorbed. Likewise, we have to use the control rods in the process if you want to control. Okay. So here, those control rods suppose absorb the 6 neutrons here. Remaining 3 neutrons should participate in the reaction. They will participate in the reaction in two ways. One, if you are able to decrease their energy to thermal energy, that is 0.0226 electron volts, or else if you take the mass whose size is more than the critical size. Here, problem with the critical size is outside certain closed rooms, we can take the critical size in tons, Nana. But if you want to do this experiment in a closed room, you can't take the mass in tons. Okay. So here we usually take that mass in like in grams or kgs, not in tons. Such time, this phenomenon won't occur. The remaining 3 neutrons easily pass through the matter and they will escape, and that leads to K less than 1, so that the process will shut down. Means the the reactions won't occur further. This is the problem. That's why here we require the help of some other one. Whose are the remaining 3 neutrons having the energy nearly 2 MeV should be slowed down. Slowed down means decreasing their energy. Who will decrease the energies are? Okay, in the closed rooms. The one used to decrease means not absorbing. Just after passing through such a type of rods, their velocity will be decreased. It means their energy will be decreased. Such a type of rods here used are called as moderators, Nana. So we take here moderators. Next point. Okay. Moderators. What is the purpose of moderators, sir? They slow down the velocity of electrons, sorry, velocity of neutrons. Okay. And decreases their energy to thermal energy. Okay, 0.026 electron volts. Okay, who will do such a type of help for us, sir? Decreasing the velocity, energy from 2 MeV to 0.026 MeV. Okay, without considering the critical size, without taking the critical size. Okay, even though the mass what I am taking here is less than the critical size. Okay, that function will do. Few here, which are hydrogenous, any hydrogenous substance. If you take hydrogenous substance means compared to the neutrons inside the nucleus, there should be more number of protons. Such type of elements are called as hydrogenous substances. So example, hydrogenous is taking like a heavy water. Okay, or graphite you can take, or beryllium you can take, even beryllium oxide also preferable. Okay, beryllium, spelling mistake I think, beryllium here, yeah, or beryllium oxide, etc. you can take. Okay, or they decrease the energy of neutrons. Okay, this is the other material which can help you in a closed room without taking the critical size. Okay, will slow down the energy of those remaining 3 neutrons here in the present generation. Those 3 neutrons supposed to participate in the reactions with the 3 uranium atoms here. Okay, then immediately again you will get 9 here. Again same phenomenon. The out of 9, again we have to absorb 6 neutrons here with the control rods. and 3 neutrons with moderators here slowed down. And again, we are going to initiate the reaction. Means observe here, in every preceding generation, you are seeing 3 only. Okay, preceding generation compared to this one, 3. Again, compared to this one, present generation, preceding generation, here 3. Again, same thing. You are maintaining 3, 3, 3, 3 here. Means you are maintaining k is equal to 1 steadily. That's why here it is not leading to chain reaction. Why? Because k is not greater than 1. Not chain reaction means not enormous amount of energy is released to use it for demolition. Okay. So here some amount of energy is released. That energy you can utilize for useful purposes, like converting into electric power. The best example is. Okay. This is the basic principle of the construction of nuclear reactor. Okay, all of you understood what I told here, Nana? The uses of control rods and moderators who play the major role here in the nuclear reactor after constructing the reactor. Or any doubt here related to control rods and moderators?
సార్
Yes,
ఇవి ఎక్కడ ప్లేస్ చేస్తారనేది నాకు డౌట్ సార్.
the nuclear reactor lo at the core part they place. Okay, that I will explain there in nuclear reactor.
ఓకే సార్.
Okay, so we are taking the help of these control rods here. Okay, but keep in mind here we are maintaining k equals to 1 in the reactor, no problem. But the disadvantage is the energy released there should not be converted into demolition energy. That should be converted into some other form. Some other form means whatever the energy released should be absorbed by someone. That's why here in the process, in a closed room where you are doing these things, that should be absorbed by someone. For that purpose, we use one more here, that is called as coolant. Even in cars, bikes also we use the coolants, Nana. Okay, to decrease the heat energy generated in the car. That's why we're able to drive for us together without stopping the car in the middle. Okay, coolant oil there we use. In the same way, who will cool the nuclear reactor core parts are? Okay, where the energy released, who will absorb? Okay, means here we require good absorbers of like the energy. Okay, here that coolant it the coolant it absorbs the energy released in the reactions, in the fission reactions. Okay, who will absorb this energy, sir? Okay, in the same way, you take a few examples here. Example, air, absorber of heat, or carbon dioxide. They are gaseous coolants. If you want liquid coolants, water or any organic liquid, you can take. Okay, or even you can take helium also. Okay, or liquid sodium you can use. Like here, few are there which are helpful in absorbing the energy released in the reactions, etc. Okay, here you can use, that is your wish, Nana. You can use the gaseous coolants or liquid coolants. That is your wish. Okay. Out of all these coolants absorb the energy. They absorb the energy released in the reactions. Okay. Out of these, again, sir, here you said the best moderator, the best coolant. Here I told the best moderator, Nana. Cadmium rod. Yes, best control rod, best moderator.
హెవీ వాటర్.
I did not mention here. Best moderator is heavy water, Nana. Okay, so here I add one more point. The best moderator is heavy water. Best control rod is cadmium. Okay, in the same way, best coolant. Who is the best coolant here? Do you know, ever can tell us, sir? The best coolant in nuclear reactors, who will absorb lot of energy? That is liquid sodium, Nana. Okay, so liquid sodium is the best coolant. It will absorb more amount of energy released in the reactions. Okay, that's why if you want the better results, there in place of control rods, you can use the cadmium rods. In case of moderator, you can use the heavy water. In case of coolant, you can use the liquid sodium for best results. Okay, if they are not available, you can replace with other. Yes, any doubt?
సార్ ఆల్రెడీ మనము న్యూక్లియర్ రియాక్టర్స్ నుంచి వచ్చే ఎనర్జీని ఎలక్ట్రికల్ ఎనర్జీలోకి మారుస్తున్నాం కదా సార్.
కరెక్ట్ నాన్న, మార్చాలంటే డైరెక్ట్లీ ఇట్ వోంట్ బి కన్వర్టెడ్ నా. It should be absorbed by someone, and that someone should release the energy to convert that energy into electrical energy or some other.
అంటే ఇప్పుడు లిక్విడ్ సోడియం నుంచి వచ్చే ఎనర్జీని ఎలక్ట్రికల్ దాంట్లో మారుస్తారా?
దాన్న మీకు ఎప్పుడైనా ఎలక్ట్రికల్ ఎనర్జీ రావాలంటే దట్ షుడ్ బి కన్వర్టెడ్ ఇంటూ మెకానికల్ ఎనర్జీ. అంటే మనకి ఈ హైడ్రాలిక్ ఎలక్ట్రిక్ పవర్ స్టేషన్స్ చూస్తే నీకు అర్థమవుతుంది. టర్బైన్స్ ఉంటే టర్బైన్స్ వాటర్ కంటిన్యూస్. ఎస్ ఆ మెకానికల్ ఎనర్జీ లేటర్ దే కన్వర్ట్ ఇంటూ ఎలక్ట్రికల్ ఎనర్జీ. అది జరిగేది ప్రాసెస్. మరి ఈ ఎనర్జీ రిలీజ్ డైరెక్ట్ ఎనర్జీ యూ కాంట్ సెండ్ టు ద టర్బైన్స్ నా దేర్. మరి టర్బైన్స్ కి రావాలి అంటే సమ్ ఏదో ఎయిర్ అంటే గ్యాసియస్ వన్ ఆర్ ఎల్స్ సమ్ లిక్విడ్ వన్ షుడ్ ఫాల్ ఆన్ దోస్ టర్బైన్స్. మరి అవి ముందు అబ్జార్బ్ చేయాలి కదా. దట్స్ వై హియర్ వి యూస్ ద కూలెంట్స్ inside the reactor.
Okay na? Okay sir.
And one more required here before starting the nuclear reactor. What I said previously, in the fission of suppose if you take 235, the daughter nuclei, the fragments are also the radioactive but having more half-life time, and these are very dangerous compared to the parent. Daughters are very dangerous than parents. That's what I'm saying. Okay, so these are more radioactive and they live for long time compared to the uranium-235 parent nucleus. Okay, why? Because their half-life time is more compared to uranium. That's why here, even though the fission occurred, we have to think about the daughters. Okay, they are radioactive means suppose here after uranium, whatever you are taking in the nuclear reactor, after completing the fission process, we have to remove these fragments from the core part now. When you try to remove these fragments from the core part, they continuously emit the radioactive rays and they pass through the human bodies. Humans only will do such type of things. They pass through the human bodies and can damage anything here in the human body, lead to cancer. That's why we require, even though someone, suppose you did some PhD and want to join as a scientist in the reactor, even you also should be protected from these radiation. So we require some shield which will protect you from the radiation, either from the parent or from the daughters. Okay, so we require some protecting shield here. So another major part for the reactor is protecting shield. Sir, from where those radiations are coming out? From the core part of the reactor. So core part should be protected from a shield. So these alpha, beta, gamma rays, who will absorb more, sir? The advantage is concrete will absorb more, Nana. okay, preventing the radioactive effect. That's why here, during that process of working in the nuclear reactor, okay, the core part is completely shielded with concrete walls, okay, using the concrete bricks there of several feet, nearly 8 feet, Nana. Means the thickness of each wall around the core part is nearly 8 meters. That's what I'm saying, not 8 centimeters. Almost the length of one hall in double bedroom house. Okay, that much wall you can see there as the protecting shield here around the core. That's why here protecting shield, it will protect the human beings from the dangerous radioactive rays. Radioactive rays emitted by either from the parent nucleus, that is called as fuel, or fragments, the daughter nuclei. Okay. Example, what I said here, the concrete, it can be used as a protecting wall around it. And that too, lead is also good absorber. That's why if you want to enter into the room of that core as a scientist to watch something inside, you can wear the lead suit. Okay, like the astronauts wear the suit there to maintain the weight. Now, likewise, they use a lead suit. That lead suit they wear and they enter into the room to protect themselves from the radioactive radiation if they want to enter into the core part. Outside, no problem. Why? Because already core part is protected with the concrete walls. Okay, and they are used. And inner walls of that concrete also already coated with lead nano. Okay, why? Because lead and concrete in combination will absorb more the radiation. That's why concrete and lead are used inside. Both are best protecting shields, Nana. Okay. The thickness of concrete wall, which can concrete wall, which can absorb the radiation, is nearly 8 meters. Okay, means thickness of each wall should be 8 meters. That's why we won't wear the concrete suits, Nana. Okay. So we use the lead suit. Lead, the thickness of lead will be very less, like in few millimeters. That will absorb the radiation quickly. Okay. So here altogether, we are using both concrete walls and lead coating around the concrete wall. Okay. Means that is lined inside with lead. Okay. So do you have any doubt related to here the coolant and protective shields, Nana?
No, sir.
No doubt. So I think you understood all the parts here, which are helping here to construct the reactor now. Okay. Now we are going to the reactor part here. This is nuclear reactor. What, Aditya? Do you have any doubt? Okay, nuclear reactor. in this nuclear reactor, the basic principle is?
Sir, by mistake, sir.
Okay.
Sorry.
Okay, no problem. Basic principle in the reactor is K is always to be maintained as 1. Yes.
One doubt. In bombs, we won't have all this, no, sir. Means control rods.
That is coming outside, and the bombs are used for what purpose? For demolition purpose only, na?
Yes, sir. Means we don't need
for
to.
demolition. Yeah, no need to take any precautions here. If you want to use that for utilization, then we need some precautions.
Okay, sir.
All right. So K is always to be maintained as 1. Okay, this is the basic principle. And here, who construct the first reactor? Scientist name for BITSAT exam. These type of questions they ask in BITSAT. First reactor, nuclear reactor. Nuclear better, right? Fission reactor was constructed by Fermi. Okay, in the reactor, the chain reaction, since K equals to 1, is under control. Okay, so it is not uncontrolled chain reaction. It is controlled chain reaction in the reactor. That is controlled chain reaction. Controlled chain reactions. Okay. Occur inside. Okay, not out of control. That we have to do. Who the scientists have to do. It is their job. They have to maintain K always equals to 1 without sleeping, without taking rest. Okay, that is one thing, main thing we have to maintain. And here, since we are using the control rods and moderators, okay, there is no critical mass here. Okay, critical size or mass while using the fuel. Okay, this is one more point. Fuel is what? Fuel is the source of fission reactions. Okay, and who are those fuel? You can use uranium 235 or plutonium or thorium, etc. Plutonium symbol PT only, Nana? Correct, na?
PT platinum.
Platinum, sir. PT.
Plutonium మరి
PU or
symbol
P1.
PL ఎవరికి
Sir,
ఐడియా లేదా?
PU అనుకుంటా సార్.
PU నా? సో నిన్ను నమ్మి PU అని
ఎందుకంటే
రాయనా?
ఫస్ట్ థర్డ్ వాడతారు.
ఓకే ఓకే.
PU,
సార్
sir.
పిఓఎస్ సార్ చెక్ చేశాను.
రైట్, అయితే కరెక్ట్. యురేనియం, ప్లూటోనియం, థోరియం ఎక్సెట్రా వి యూస్ ఆర్ ద ఫ్యూయల్స్ in the reactor. Okay. Next here we are coming to, this is one 8 marks very important question for board exams, Nana. Very important, and it is damn sure question from this chapter. Why? Because nuclei is the 8 marks chapter, Nana, third 8 marks chapter. Okay. So here either nuclear reactor or radioactivity, you will get the questions from this chapter for 8 marks. Out of these two, surely you will get 8 marks. So we have to explain about the nuclear reactor briefly. Okay, suppose this is the protective shield. Means a concrete wall, inner side the lined with what lead. Okay, in this protective shield here we are taking inside like a few cans like this, aluminum cans, and in those aluminum cans we take the fuel, uranium or plutonium or thorium. These are all aluminum cans. Okay, here I am writing, or the aluminum cans in which the fuel is taken. Okay, under the critical size. Means less than, better, right? Less than the critical size. Taken less than the critical size. Oh, better I write in the next page. Less than the critical size. Okay. So here what you do, sir, in each can just initially they initiate the reaction with a thermal neutron. Initiation is required. Okay. So next point, what they say, the reactions are initiated with the neutrons. Okay, in case of uranium 235, thermal neutron is used. Is used to initiate the reactions. Okay, right. So here, after initiating the reactions, here only we have to take care. The scientist has to take care here. What? Using some calculation, he has to dip the coolants. Sorry, not coolants. What are they? The moderators and control rods. Okay. Maintain certain time here. These are control rods, what you have to dip in the can. And these are other black one are moderate, or else black one are the control rods and the blue one are moderators. Okay, that I mentioned here. Next page, here the black one, I am taking it as next point, are the control rods. Okay, and when you come to IPA, you have to say about these points under the control rods. In 8 marks question, you have to write all these points. Okay, and here the blue one is, I'm taking it as moderator or the moderators. Again, under the moderators, those points you add here for IPE purpose. Okay, and here time, using some calculation, you have to dip them inside the can to absorb and to slow down. Okay, to measure that calculation only we are doing the PhD on this particularly radioactivity. Okay, what calculation we have to do? Okay, that thesis we have to submit to the professor. Okay, that calculation they will do, scientists will do. Now you understood, Mr. Mandua?
Yes, sir.
Yeah, for that calculation only you are doing the PhD. If you want to join as a scientist in the reactor, nuclear reactor. Okay. Here, in such type of reactor, these two will absorb and slow it down. Okay. All those are human calculations. Sometimes the natural phenomena, they behave beyond the calculations of human beings. Okay. They are called natural disasters. Okay, they are out of our control. Whatever we calculate, they won't behave. The nature won't behave like. So such type of natural disasters also will occur inside the nuclear reactor. Okay. If that kind of disasters occur, then who will here ready to join in a reactor as a scientist? Why? Because if disaster occurs, no one will live inside the reactor. That becomes uncontrolled, K becomes much greater than 1, that leads to demolition. Okay. So at that time, sir, suppose sometimes it leads to uncontrolled, sir. At that time also we have one fetching. What, suppose you are feeling that more energy is releasing and then energy rate is increasing in the reactor, means it is turning to like uncontrolled. If you feel as a scientist, simple, because of what that is becoming uncontrolled, because of more number of neutrons are participating in the reactions beyond your calculation. That's why simply you dump, not don't dip. Okay, instead of dipping the control rods, this time you dump the control rods in the cans, so that all the neutrons will be absorbed by the control rods and reactions will shut down. Okay, after shutting down, again, if freshly you can start the reactions again by removing that fuel from the cans and placing the fresh few new cans there, and again you can start the reactions. Okay, there is one advantage, okay, for the natural disasters. Now you understood, Nana? That's why happily, if you want to join there, you can join there. No need to worry about in the nuclear reactor as a scientist. Okay, Nana? Right. These are controllers and model. Nana?
Sir, if we take the can more than critical size, then what will happen?
You can't take, Nana. We need tons of matter, na. Tons of matter. You can't fill in the cans, na.
Yes, sir. Okay.
Aluminum cans like milk cans, Nana. The milk wala that carry the
Yes,
cans,
sir.
na.
Yes, sir. Yes, sir.
Okay, who will come to
Okay,
house
sir.
and they pour the
Yes,
milk,
sir.
like such type of
Yes, sir.
aluminum cans. There you can't fill thousands of kgs of matter inside, na.
Yes. Okay.
That will be like 1 kg or 2 kg. Okay, all right.
Yes.
Next,
Okay, sir.
any other doubt?
No, sir.
Likewise. And next here, yes, Aditya.
Sir, how can they store such large energy, sir? Any chances?
Not store, Nana. They absorb immediately. That's what I'm going to say here. Around this concrete wall, you place the circulated pipes, Nana.
Okay, sir.
Okay. Through that pipe, you circulate whatever I said, that coolant, so that the coolant will absorb the whatever the energy here coming out. Okay. And that
Okay, sir.
energy means of liquid sodium, again you pass through certain propellers and then send on to the turbines and you convert that into mechanical energy.
Okay, sir.
Yeah.
Sir,
So here later you have to yes.
సార్ అంటే ఆ రియాక్టర్స్ నుంచి వచ్చే పొగలు ఉంటాయి కదా అవి సోడియం లిక్విడ్ సోడియం సార్
ఎస్, అంటే అవి ఏమవుతాయి, బర్నింగ్ స్టేజ్కి వెళ్తాయి. అంటే లైక్ ఏమనాలి మీకు, కెమిస్ట్రీ ఏదో అంటారు కదరా, మెల్టింగ్ పాయింట్, బాయిలింగ్ పాయింట్కి వెళ్ళిపోతాయి. they will go to boiling point.
ఓకే
Now you understood?
ఎస్ సార్
అంత టెంపరేచర్ వస్తుంది నాన్న అక్కడ మనకి. అప్పుడు మనం వీ కెన్ ఫైండ్ దట్ ఇట్ ఈస్ ఆల్మోస్ట్ ఎట్లా అంటే బాయిల్డ్ సోడియం లిక్విడ్ వీ విల్ సీ వైల్ కమింగ్ అవుట్ ఆఫ్ దట్ పైప్.
సార్
అంటే ఇట్ మే బి ఎవాపరేటెడ్ ఆల్సో సమ్ టైమ్స్. ఎస్ ఎస్
సార్ ఇందాక మీరు చెప్పారు కదా సార్ ఈ అల్యూమినియం దాంట్లో రెండు ఇప్పుడు రాడ్స్ పెట్టినప్పుడు న్యూక్లియస్ ఇట్లా పోతుంటాయి కదా, మళ్ళా మీరు అది తీసేసి మళ్ళా పెట్టుకోవచ్చు అన్నారు కదా, మళ్ళీ దీనికి ఉంటాయి కదా సార్ ఈ రాడ్స్ కి ఏమైనా ఎఫెక్ట్ అవుతుందా సార్ దానివల్ల?
ఏ రాడ్స్ ఉంటాయి?
కండక్టింగ్ రాడ్స్
కంట్రోల్ రాడ్స్. ఓకే ఓకే.
కంట్రోల్ రాడ్స్ దానివల్ల ఇప్పుడు ఇందాక మీరు అల్యూమినియం ఫస్ట్ దాంట్లో పెట్టినప్పుడు అప్పుడు కొన్ని న్యూక్లియర్ రియాక్షన్స్ అయ్యి దాని తర్వాత కరెక్ట్ గా స్టేబుల్ చేసే వరకు చేస్తారు కదా సార్. దాని తర్వాత మీరు ఏమన్నారు అవంతా తీసేసి చేసుకోవచ్చు అన్నారు కదా, అంటే ఇవే రాడ్స్ యూజ్ చేస్తారా సార్? మళ్ళీ వేరే యూజ్ చేసుకుంటారా కొత్తవి?
అది మన ఇష్టం కదా నాన్న. ఇక ఆ కంట్రోల్డ్ ఫంక్షనింగ్ మనకు వద్దు అనుకుంటే వి యూస్ ఫ్రెష్ కంట్రోల్ రాడ్స్. వాట్ ఈస్ దే? ఓకే,
అంటే మళ్ళీ ఏమైనా ఎఫెక్ట్ అవుతుందని అడుగుతున్నారు, దాన్నే యూజ్ చేయాలా అని.
అది నాట్ నెసెసరీ. ఇప్పుడు మనకి వాషింగ్ మెషిన్ కి లోపల ఉన్నటువంటి వీల్ పాడైంది అనుకో, రిపేర్ చేసుకోవచ్చు, యూ కెన్ రీప్లేస్ ఇట్. అది నీ ఇష్టం.
ఓకే
రైట్. ఓకే రైట్. నెక్స్ట్ ఎనీ అదర్ డౌట్స్ నాన్న? ఓకే రైట్. Then here when you come yes Nana, any doubt? Okay, when you come to IP again, here you have to write about those two Nana, protecting shield and then this coolant. Those 2 points you add for IP there. Okay, means all these points you add when you come to write that LAQ Nana. Okay, along with these points in the nuclear reactor. Okay, next, protecting shield, no need to explain, already I explained. And the coolant here circulated around the core part here, that already I explained there. The coolant, what is the purpose of coolant? And we take out that energy, and that energy we use for our purpose. Means the wasting energy you are converting into utilizing energy, useful energy. Okay, this type of reactor where you are extracting the energy and to use it for human purposes, okay, usages, such type of reactor is called as power reactor Nana. That's why I call where the energy is converted into the useful energy by using the coolants in the reactor. Such reactor is called power reactor Nana. Okay, this power reactor is not there here in Hyderabad. That's what I told previously. This power reactor is there in Chennai. This power reactor is there in Trivandrum. This power reactor is there in Mumbai. Means at Trombay, what we say. Okay, near Trombay. So these are the power reactors in India, where the energy from these in the fission process is converted into useful energy in the power reactor. These are all theoretical points related to power reactor Nana. Okay, when you come to objective like mains type of exams and advanced type of exams and MSET type of exams, here they ask the numerical questions related to power reactor. Okay, how to calculate the power of a reactor? Okay, that one, what he says, this is what I'm going to calculate, power of a reactor. How I calculate? Sorry. Suppose you are taking some mass of uranium fuel. M is mass of fuel, which is completely utilized. Why? Because we are not taking critical size. Okay, total mass is utilized there, mass of fuel. Okay, under the vision of one very good scientist. Okay, not lazy scientist, without wasting the mass. This is the mass of fuel, and that mass is completely utilized for the reactions. Okay, then suppose in each reaction, if I take E is the energy released in each reaction. Okay, M mass of fuel is used in a time T, time for utilization. Okay, then how much power is generated? Power means nothing but work divided by time. Work is nothing but energy divided by time. How much energy is released in the time T by utilizing M mass? That one all of you know. In case of uranium, you can say simply, sir, 235 grams of uranium, if I take, I will get 200 MeV, sorry, Avogadro number of nuclei or atoms will be there, sir. If I take M grams, sir, then I will get M into Na by 235. 235 is nothing but mass number, molecular weight. Okay. Number of nuclei present there. Okay, when each nucleus is participating in the fission reaction, this is the energy released. One nucleus undergoes fission, you are getting E energy. When these number of nuclei, M into Na by M number of nuclei participate in the reaction, how much energy will be released in a time T? That is the power. So you understood this concept, Nana? Any doubt here?
Understood, sir.
Right. That's why straight away I'm writing here without the explanation. Okay. If in a time T M grams, keep in mind mass of fuel in grams. Why? Because Avogadro number said 235 grams, and means you are taking M in grams. So small m also should be in grams, even though they give the mass in kgs or tons. While substituting in the numericals, you have to convert in grams. This is very important. Don't do that mistake here in exam. Okay. Then here, how much energy will be released in a time T? Power. That implies power of the reactor. P is equals to the energy released E into in each reaction into number of reactions occurring, M into Na by capital M in a time T divided by T. This is the formula to find out the power of a reactor. Okay. Any doubt here in the power of a reactor?
No, sir.
Right. And you are calculating the
No,
power
sir.
in watts only, Nana. In watts, not in like the energy you are not taking in MEVs, energy you are not taking in kilowatt hours or some other units. You are taking this total energy in joules, joules per second in watts. I'm calculating the power in watts only. Means you have to convert whatever the energy they give here into joules. Why I'm saying in case of uranium, in each reaction, I will get 200 MeV, Nana. This direct 200, you should not substitute in place of E. That's what I'm saying. This one, you write it as convert into joules, 1.6 into 10 to the power minus 13 joules when you come to numericals. Okay, what the case we have to take here? E should be in joules, M should be in grams. Okay, if you take these two cases here, you will get the answer in watts. Okay, is it clear?
Sir, we will use this, sir, means in to provide electricity to our houses. Means
Ah,
they
yeah,
will
yeah,
use
yeah.
this.
This using this one only, they create some power there in the reactor.
Okay, sir. Means this can be used commercially, no, sir. This method.
Commercially. Yeah.
Okay, sir.
By that only we say the power of a reactor. So that how much coolant we have to send there for the reactor. What will be the
Okay,
power of
sir.
reactor? By that, how much coolant we have to send.
Okay, sir.
Okay. Shall I stop the class now, Nana? Do you want the
Okay, sir.
pages here?
Yes, sir.
Anyone want the pages? Okay, right. First page. Second one. And the third one. So I'm going to stop it.